Hello, today we are going to go over how to calculate the volume of a cylinder. So in case you guys don't know what a cylinder is, I want you to imagine a can of food. That's what a cylinder looks like. So the first step asks us to convert the 2D shape into a cylinder. So if we look at this 2D shape they gave us kind of this circle. It looks like an oval, but it's actually a circle. If we wanted to make this shape into a cylinder, it's going to look something like this. All right. And if we were to look directly down, think about if you were looking at a can of soup, you would have a circle on the top and the bottom. So it says, what 2D shape is the base of a cylinder, and how do you know? So if we look directly at the top or the bottom of a cylinder, we know that we see a circle. And really what they mean by the base in this case is we're taking the base and we're just stretching it up. The next step says label the base and the height of your cylinder in your drawing. So let's go ahead. I'm going to color in the base as blue. In this case, this is our base. We could go ahead and say base. And then the height is going to be the distance from here to here. The height is how tall the cylinder is. The next question says, what is the area formula for the base? So if you recall, earlier this semester, you hopefully learned how to find the area of a circle. And we know that the base is a circle. And to find the area of a circle, we use the formula pi times radius squared. And then it says, what is the volume for a cylinder? So we know that we are stretching this base, which is a circle, all the way up. So what we want to do is we want to multiply the area of this base times the height. So it's going to be pi times radius squared times the height. So one thing I want to point out, this isn't in your notes, but I put the SAT formula sheet in here. If you look on the SAT formula sheet, they have a cylinder. The formula, the volume of a cylinder, is pi times radius squared times the height, which is what we just learned. So now we have our first example. It says, find the volume, round your answer to the nearest tenth. And in this case, they want us to use 3.14 for pi. So if they're asking for the volume of this shape, we know that this is a cylinder here. So we're going to use the formula pi times radius squared times the height. Now in this case, the radius of this cylinder is going to be 6. And our height is going to be equal to 5. So we could go ahead and plug these into our formula. We have pi. Oh, and actually, they told us that they want us to use 3.14. So now I'm going to go ahead, instead of putting in the pi symbol, I'm going to write 3.14. And now I'm going to plug in my radius, which is 6. So we have 6 squared times the height, which is 5. So we can go ahead and plug this into our calculator. Now, when you plug this in, you should get 565.2. Now, since this is volume, we are going to have centimeters cubed. And this should be your final answer. All right, so for our next example, it says, use the figure BLOX to answer the following questions. It says, what solid is produced when figure BLOX is rotated about line M? So I want you to try and imagine what would be created if you were to rotate this rectangle about line M. Now I did find kind of an animation thing here to help you visualize this. So what I'm going to do is I'm going to go ahead and rotate it. You can see we have a rectangle right there, and it is getting rotated. When you rotate a rectangle like that, you form a cylinder. So we can answer the question, what solid is produced when this is rotated? We're going to produce a cylinder. Next, what is the volume of the solid produced by rotating BLOX about line M when XO is 10 and BX is 14? So if you kind of imagine this getting rotated, in this case, the 10 is actually our diameter of our circle, right? It goes all the way across. We're going to want to know the radius. So if the diameter is 10, our radius is going to be equal to 5. And then our height is going to be 14. So we know our radius is 5, height is equal to 14. So now, again, we're going to use our formula, pi radius squared times height. So we have pi times 5 squared times our height. So you can go ahead, plug this into your calculator. And when I plugged it in, I got 350 pi for an exact answer. And then for an approximate answer, I got 1099.56. So if we wanted to round that to the nearest tenths place, we could say 1099.6. And then the units on that are going to be centimeter cubed. So that is our answer there. All right. So now we have example 3. It says, which can of Coca-Cola holds more soda? So I actually want you guys to try this problem out. Let's call this first can of the regular Coke can 1, and the can of Diet Coke will be can 2. So I want you to go through and calculate the volume of each of these cans. Since it's asking how much soda it holds, that's referring to the volume. So go ahead and calculate the volume of these cans, and I want you to submit your answer. Tell me what you get. All right, so let's go ahead. I'm going to go through and calculate this out with you. So for the first one, they tell us that our diameter is 2.5 inches and the height is 4.75 inches. So we know that our formula for the volume of a cylinder is pi times the radius squared times the height. So our height is nice and obvious. They tell us that our height is equal to 4.75. Now, they don't give us our radius, but they do give us our diameter. And we know that the radius is always equal to half the diameter. So in this case, our radius is going to be equal to 1.25 inches. So at this point, we can go ahead and plug this into our formula. We know our volume is equal to pi times our radius squared, which is 1.25 squared, times 4.75. You can plug this into your calculator, and I got 23.32 inches cubed. So that is my answer for the first one. Now let's go ahead and calculate the volume for the Diet can of Coke. Again, they gave us our height, which was nice and easy. Our height is 8.2. Again, they gave us the diameter. We need to go in and find the radius. Our radius is going to be 1. We plug it into the formula. which is pi times our radius squared times 8.2. So when you plug those in, you should get 25.76 inches squared. And that is what I got for my answer. Oh, I'm sorry, not inches squared. It should be inches cubed. It's volume. All right. So then to answer this question, it says, which one holds more soda? Well, can 2 is going to hold more soda, our diet can of Coke. Now let's go ahead and try example 4. We'll start with 4a. It says, if the radius equals 2 centimeters and the height equals 5 centimeters, the volume of a cylinder is approximately 63 centimeters cubed. Suppose you wish to increase the volume of the cylinder to 64 centimeters cubed. If you keep the radius of 2 centimeters, what should the height be? So now we are kind of working backwards. Before, we were taking the radius and the height, and we were calculating the volume. Now we're going to take the volume in the radius and work backwards to find the height. So again, we're going to use our formula for the volume of a cylinder, which is volume equals pi times radius squared times the height. So we can go ahead and write down the information we have. We know that the radius is equal to 2, and that the volume is equal to 64. So what we can do is we can plug in all of our known information and calculate the height. So we're going to do 64 equals pi times our radius squared times the height. So since we're solving for height, we need to get rid of everything else, and we can just divide them out. We're going to divide both sides by pi 2 squared. And we can plug that into our calculator. 64 divided by pi times 2 squared. When you plug that in, you should use parentheses on the denominator there. So when you plug that into your calculator, you should get 5.092, which I approximated to be 5.1 centimeters when rounded. So the height would be about 5.1 centimeters. Next, it says, suppose you wish to keep the height of 5 centimeters. If you still want to increase the volume of the cylinder to 64 centimeters cubed, what should the radius be? So before we were solving for the height, now we're going to solve for the radius. Again, we're going to start with our formula. Volume equals pi times radius squared times height. And the information they gave us was that our height was 5. And again, we want our volume to be equal centimeters to 64 centimeters cubed. So we plug that in. So now we need to solve for the radius. So we're going to get rid of everything but the radius squared. Move it to the other side. Isolate the radius. So we're going to divide by pi times 5. So we can plug that into our calculator. 64 divided by pi times 5. And that's going to equal our radius squared. So when you plug that in, you should get that radius squared is equal to 4.074, and it's a very long decimal, so we'll just go ahead and leave it there. Now, we're not done here. They asked for the radius, and we solved for radius squared. So in order to get our final answer, we're going to have to go ahead and take the square root of both sides. So when you take the square root of that number, you're going to end up with radius equals 2.0185, which I rounded to 2.0 centimeters. Now notice for both the radius and for the height, the units were just centimeter because that's one-dimensional. The volume is going to be three-dimensional, so that's why it's centimeters cubed. All right, so for the last question, it says, what if you decide to change the radius to 5 centimeters and the height to 2 centimeters? Would the volume be the same as 4A? So if you recall, in 4A, our volume was, our volume was 63. That's what they're referring to there. So we started out with a cylinder with a volume of approximately 63. So we'll go ahead, I'll kind of put parentheses there. Is this going to be equal to 63 centimeters cubed? So I'm going to go ahead. I want you to go ahead and answer the question, see what you get. So now I'll go ahead and solve the problem. They gave us that the radius is 5 and that the height is 2. So again, we're going to plug this into our volume of a cylinder formula, which is volume equals pi radius squared times the height. We've got pi times, in this case, our radius squared is going to be 5 squared times 2. And when I plug that in, I got that it was equal to about 157.08, which does not equal 63. So your answer to that would be no.